error free or with error is to just replace those known roots to the received code polynomial, and replacing those known roots to the received code polynomial and those roots making these received code polynomials 0. So we can come to the conclusion that the received code polynomial is error free. Okay. The roots, okay, I'm just repeating it. Maybe this is difficult to understand. If the roots, okay, we have calculated the roots of the generator matrix, actually generator polynomial, okay, and we know that the roots of the generator polynomial is equal to the roots of the generated code polynomials. So we have generated the code polynomials at the encoder, or you can say at the transmitter. We have generated the code polynomial, and we also know what is the roots of the generated code polynomial. Okay. Now we have received a code. We have received a code polynomial, that is a received code polynomial, and this received code polynomial will be error free, considering that those roots of the generated polynomial will also satisfy the received code polynomial. That means when I'm replacing x, I'm replacing x with those known polynomial, with those known root in our received polynomial, then the received polynomial equation will become 0. So that was the technique we have already discussed. So that is basically written here, that by substituting in the expression for the received polynomial, the roots alpha and alpha square. Okay, if you substitute alpha and alpha square in the received polynomial, for instance, it is possible to find a system of two equations. It is possible to find a system of two equations that allows the solution of two unknowns. So from this we are considering what is happening in the receiver. Okay, so at the receiver we have already received a polynomial equation where we are replacing alpha and alpha square. Okay, so for instance, it is possible to find system of two equations that allows the solution of two unknowns, which are the position and values of the single error in that polynomial. That means when we have two equations, system of two equations that allows the solution of two unknowns, and how we are doing this, we are basically replacing the received polynomial by the roots alpha and alpha square. So we are replacing one time at a time. One time as alpha, we are replacing alpha, and in another equation we are replacing alpha square. So by doing this, we are generating two equations of two unknowns, and they are the positions and the value of the single error in that polynomial. So from this we can say for the single error to detect or to correct the single error, we need two equations. To detect and correct m number of error in the received polynomial, we need 2 into m, that means 2m number of equations, right? This is nothing but from your vector, that means vector arithmetic part. Okay. So when we have to find single error in the received polynomial, we need two equations of two unknowns, and that two unknowns is basically the position and the value, right? But when we need to calculate m number of error in the received polynomial, then we need 2m number of equation, right? Okay. Now come to the second paragraph. What is this? Tell me. In order to correct an error pattern containing two errors. Okay. So for the single error, we need two equations. In order to correct an error pattern containing two errors, so for the two error, what we need? We need four equations. For instance, it would be necessary to have a system of at least four equations. As I've told you that for the m number of error, we need 2m number of equations. Okay. So here, in order to correct an error pattern containing two error, we need four equations. Okay. To solve for the positions and the values of the two error. Okay. And this would be case of a linear block code able to correct error patterns of size t equals to 2. That means error correction capability, which is t. So in this case, the second para, in this case, at the second para, t equals to 2. The first para, t equals to 1, because we are concerning about, we were concerned about single error. So for the single error, we needed two equations, but here it is two error. So we need four equations. So t equals to 2, equation will be 4, right? Okay, done. Now, in the case of Hamming code, there is just one additional root, alpha to the power 4, associated with the additional equation. That means this, making only 3 in all. That means there was alpha and alpha square, right? Alpha and alpha square, and by replacing alpha and alpha square, we were making two equations for the single error. Now, when we are concerned about two error, we need four equations. But four equations means we have to replace four roots. Four equations means we have to use actually four roots in four equations. That means alpha squared, alpha to the power 4, and another one. Okay, but that one is missing. Have you understood? I think so. So when we are determining two error in the received code polynomial, we have to make at least four equations. But here we have only three roots: alpha square, and alpha to the power 4 associated with the additional equation. Okay, so making only 3 in all. So we need another one to make 4 equations. So this is not enough to allow the construction of a set of 4 equations. Okay, the minimal requirement for correcting error pattern of size t equals to 2, right? So this is in agreement with the fact that this Hamming code 7,4 characterized by the minimum Hamming distance, that is